Hello again. This is Math 1120 coming to you from the College of DuPage, and the title of this lecture is Relative Motion in a Plane. As always, please be an active learner as you watch this video. Previously, we talked about relative motion in a plane, but we were in one dimension, not two. Here, we're going to expand that discussion to talk about relative motion in a plane. So we're going to have a woman who's walking not down the aisle of a railroad car, but from one side of the car to the other with a speed of 1 meter per second. And we're going to consider the woman's position in two different frames of reference, that of the railroad car and that of the ground. And instead of a coordinate x, which we used in one dimension, we're going to use a position vector r. So let W represent the woman's position, C the frame of reference relative to the cyclist, the stationary ground observer, and T the frame of reference of the moving train. And then, so what we have in the picture then is the woman is on the train and she's moving from one side of the train to the other at 1 meter per second. The train itself is moving at 3 meters per second relative to the cyclist, and the problem is to find how is the woman moving relative to the cyclist. So you see, from a vector standpoint, the velocity of the train relative to the cyclist is 3 meters per second this way. The woman, and this is the woman relative to the train, is 1 meter per second. So we're adding those two vectors, and we have to then look at this. Now that's the hypotenuse, so to find the magnitude of the woman relative to the cyclist, we're going to use a Pythagorean theorem. And so it's going to be the square root of 3 meters whole squared plus 1 meter whole squared, 1 meter per second whole squared, square root of that whole thing, and that's going to be the square root of 10, or approximately 3.2 meters per second. And then we need not only the magnitude, but we need the direction. And so we're going to say that the tangent of this angle phi is equal to 1 over 3. And then we can find out the inverse tangent of 1 over 3 using my calculator, and I find out that that is, to the nearest degree, 18 degrees. And so we have solved this problem. Let's do another one. Suppose the compass of an airplane indicates that it's heading north. So here's the airplane heading north, and here's the other piece of the airplane, and it's heading north. That's up to the top of the page. And the airspeed indicator shows that the plane is moving through the air at 240 kilometers per hour. If there is a wind of 100 kilometers per hour from west to east, so this was north, this is west to east, like that, and that's 100. What's the velocity of the aircraft relative to the Earth? So you see, again, I have 240 this way, I have 100 this way, so I have to find the hypotenuse. Again, the hypotenuse is going to be found by 240 squared plus 100 squared and the square root of all that, and so that is 260 kilometers per hour. And the direction is going to be, the tangent of that angle is going to be 100 over 240, and I can use my calculator to find out that that is 23 degrees east of north. Let's do another problem. The lift and drag forces on aircraft are functions of velocity relative to the air, not to the ground. Consequently, pilots must compensate for the effects of wind in the air. So in this example, we'll determine in what direction a pilot must head in order for the plane to be traveling due north. So the pilot wants to be going due north, but you have a 100 kilometer per hour wind going at this angle, and the airspeed is 240 kilometers per hour. And so we want to find what's the bearing. So this is going to be, the bearing needs to be, is this angle beta. We're also going to want to know what is the net speed so you can estimate arrival time and things like that. Okay, so beta in this case is going to be equal to, we know this side and we know this side, so that is we know the opposite and we know the hypotenuse, so that's going to be the sine. So beta is going to be the inverse sine of 100 over 240. If you put that into your calculator, you'll get 25 degrees. And this dimension then is, we're going to say 240 squared minus 100 squared. The square root of all that is going to be this. So that is the square root of 240 whole squared minus 100 whole squared. That's 218 kilometers per hour. So the pilot should head 25 degrees west of north, and her ground speed should be then, or will be then, 218 kilometers per hour. Let's look at another example, and this is an opportunity for you to test what you know. This is about trucks on your highway. So truck 1 is moving in a positive x direction at 50 miles per hour, and truck 2 is moving at a velocity of minus 120 miles per hour relative to truck 1. Think about the SIG and S's, the signs. Assume subscript 1 refers to truck 1 and subscript 2 refers to truck 2. And R is the road surface. Okay, so what is the velocity of the road relative to truck 1, and what is the velocity of truck 1 relative to truck 2? And you have some choices here. Let's see how you did. You know what to do. Let's see how you did. Okay, so when we state truck 1 is moving at plus 50, it assumes its velocity relative to road. So V1R is plus 50, the velocity of truck 1 relative to road. Since in general VAB is equal to minus VA, we assume that R1 is minus 50. Similarly, the velocity of the trucks relative to one another is going to be V21 is minus 120 and V12 is plus 120. So the correct answer to this whole problem is number B. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself and of each other. May God bless you all.